So now we're going to talk a lot more technical, well, as technical as I can get into in 40 minutes. In fact, let me set a timer real quick. So all that being said, I covered how to do, how to get started with games, how to build it for, across all these different devices, how to picking a framework. Now we're going to talk about a specific framework, which is Unity, which luckily I didn't have, like, when I asked everyone to raise their hand that they were doing HTML5 or Unity, everyone raised their hand for Unity. So it would have made this a little awkward, but the majority of game developers are using Unity, so it's a safe bet to do this talk. And we're just going to talk about porting a Unity game over to our Fire devices and sort of what are the things that I've done through my own game in order to optimize it. In lieu of doing my introduction again, I'm just going to run the game. So this is my Super Paper Monster Smasher. This is Deluxe Super Paper Monster Smasher. It's the HTML5 version, which is regular Super Paper Monster Smasher. And there's a lot of stuff that I did here that I didn't do in HTML5, but it was just easier to build out these splash screens, add in this animation, going through it. I'm going to talk in a lot more depth about sort of how I optimize this for our devices. But I can use, for right now, I can just use the keyboard to switch between things. The keyboard will map to the game controller as well, just as you use the axis. As I start the game, it's really basic. You just move left and right, and he automatically eats the people. And then my son, I did this for my son. He loves it. Oh my God! When you fall through the floor, it's like it's like it's great. So I've altered this game so as you complete missions, you get a mission at the bottom. So I have to increase my score within 10 seconds, and every level it gives you a new random thing to kind of keep you engaged. And the game just goes on and on. You can infinitely smash and kill people for your heart's content. I did take out the blood. I made them little ghosts. And then you get more and more hard people, and then you'll have archers, and archers are designed to... Archers will hide behind the shield guys so that they get defense, and the shield guys keep you from moving. And, that being said, but the game has been incredibly simplified and streamlined to just work across all these different devices. So, there we go. I'm Jesse. Hi. So how do we support multiple screen resolutions? I talked about this earlier. I'm just going to assume that everyone was here for the earlier talk, so I'm just going to go right through this stuff. But at a high level, again, it's all about the aspect ratio. I make sure that I support 16 by 9 to 4 by 3, and everywhere in the middle just sort of works. And all of our devices and stuff like that. Again, let's just go through. I was talking about this earlier. This is probably the most important thing. This is another reason why I like Unity, if you're coming from the last talk, is I wrote this tool myself to just display these guides in the scene. I think if I go back into Unity, and it won't be here, it might be in the, let's see. I think it's if you select the main camera. It's going to be hard to see, and I'll zoom in. So here you'll see, this is like the weird thing that I do, right? So I designed my game to be 800 by 480. That's like a generic Android size. And then I just scale the game up and down based on that resolution, right? So here it's telling me the approximate resolution of my game on a Fire TV is going to be 1025 by 577, right? I would never know what that resolution is, because who does math like that? Rayman, right? But, and then on the Fire tablet, it's a different resolution. But this just gives me this estimate, so I know, all right, I'm scaling my game up. So ideally, I give it this, what is my perfect resolution that I designed it for? And then I have my camera logic automatically convert that for me. So, and again, I was talking about, when I go, it's hard to see here, but when I go from 16 by 9 to 8.5 or 8 by 5, I just give more pixels on either edge of the screen, right? So you wind up just stretching out the screen. I don't stretch the artwork. I just expand the view. So these are some of the techniques that I do. The other thing that I do is I have to calculate now. So we're going from the resolution is 800, it's 800 by 450. Let's double check. I'm going to do a little switching back and forth between the project. On my code here, I have this class that I wrote called Pixel Perfect Orthographic Camera. And I give it this native resolution. Its native resolution is 800 by 480. Then what the camera does is, or what the script does is it goes and it says, okay, well, what is the size of the screen? And then I'm going to scale this up until I get as close to it as possible along the width, right? And that's where we get that formula in the top where it's showing me what this sort of scaled up resolution is. And so in this sense, what winds up happening is that the UI always stays consistent, right? A button looks big on a high resolution as well as a low resolution, and I just try to get it to fit automatically. And I do this by, all I do is like here you'll see, this is a really bad example because this is this right here is a scene, and a lot of this is done with the UI. So the UI has this if you look at the Unity's new UI stuff, they do the same exact thing. They have this thing called the canvas scaler, and in the canvas scaler, I have it set to the same exact resolution, right? So I have to have two different scalers. The canvas scaler just handles all the UI. My scaler handles the camera. If I was to run the game, it'll automatically, it should just do it, but if we look here, the camera size is set to 5 or something. I'll run it, and then, oops, let me not run that on full size. It'll automatically do the conversion, and now the size is 240. This is just zoomed in really big. That's normally the game right there. So, and then you can see my guides and my markers sort of on that display. So that's like high level what I do with scaling the resolution. And once you get that formula right, it basically it works sort of everywhere. And there's a lot of like assets in the library, in the Unity asset store that do this scaling for you. The math isn't actually, it isn't that hard. I don't think I have a ton of time. I mean, let's see. Sometimes Unity likes to crash out when you try to open up MonoDevelop and you're in a presentation. We get the beach ball of death. See all my games I'm working on. The math is, this is the math. Like if you want to take a screenshot of that, that's all it is. It's really basic. All I'm doing is I'm getting I have to calculate the conversion of the pixels to units. Actually, I lied, because there's a subclass here. So here what I'm doing is so I have to calculate the scale, right? So we need to figure out what is our native scale and what is the maximum scale we can get. So I take the screen height and I divide it by the native resolution. The native resolution was the height that I gave it. And then I come up with a scale. And then once I have the scale, all I do is multiply half of the height by that scale. Unity's like coordinate system sort of like makes my head hurt because 0, 0 is in the middle of the screen. So you have to do half of the height. But anyways, all right, so that's it. It's a very basic formula. I have a way, way, way more complicated formula for a perspective camera, but the perspective camera does the same thing, right? I just measure out to the plane, and then I do the distance, and then I figure out where the camera should go. So then we talk about game input, right? So I talked about this earlier. I try to simplify the input of all my games. In this case, there are two inputs, the left side of the screen, the right side of the screen. I have a game where you're a spaceman and you explore a cave, and all it is a virtual joystick, but it's a one-button interaction. And I designed it that way, one, because I wanted it to be easy for my son to play, and two, because if I had multiple buttons, it starts becoming really like tough to deal with on the screen. So I just said, you know what, there's no combat in the game. It's just exploration. And it's a perfect example of how I designed a game around the limitations of the input. Now, when it comes to something like this, I mean, again, this is our remote. So if you're going to build for like Fire TV, for example, you want to go for the lowest common denominator. That's going to be the remote. And the remote gives you up, down, left, right, and select. And that means that if you want to reach the most people possible on Fire TV and Fire TV Stick platform, build a game that supports this. It's limiting, but sometimes limitation spawns creativity, right? And you can come up with some pretty interesting. So like this game works perfect, but all I got to do is go left and right. Also, we have a full game controller. If your game supports that and you're porting it over, just use it. Like, don't change your game to work with the remote because I just told you that the remote is the most amount of people. Generally, games that use game controllers are for a gamer audience, right? So if you want to target the gamer audience, you're already targeting with the game, just do that. So let's talk a little bit about how I abstract out input in my game. So I had mentioned this earlier on. The basic concept is this. I take all input, I don't care where input comes from, and I map them to internal values in the game engine. So my player simply looks for, is left true or false? Is fire true or false? And then I map those to some sort of adapter. So in this case, because of the way Unity works, I use the axis. So in the input class, you can go through in the axis, and you see it in a screenshot. It'd probably be easier to show in the screenshot than it is for me to dig through my code right now. But up here, you'll see I created a horizontal axis. I have an axis name called horizontal, so that's how it knows how to look up the axis from the input class. The off value is 0, right? Because a lot of axes can either go -1 to +1. So I need to tell it where is off is 0. Then I have a condition for if it's more than the off position, it maps to an enum called right. So, and I did some pretty cool stuff with this enum. Like I actually have it where the enum, I could set it up to be like a NES controller. So you have like up, down, left, right, A and B. Or it's a Xbox controller and it has up, down, left, right, A, B, or X, whatever, like the 4 face buttons, the shoulder buttons, the triggers, the whole 9, right? As 9 is in the phrase, not in the 9 buttons. I think there's more than 9 buttons. And that's like at a high level, that's sort of the concept, right? We don't want to know anything about where the input comes from. Our game engine just needs to know that input has happened. So like let's say we're on Fire TV, right? A lot of times like you have to account for the fact that controllers drop out. Like if you don't have a controller, Fire TV is smart enough to know, oh, hey, the controller's not detected. Like, okay, a big question I get from developers a lot is like, well, can I sell a controller-only game in the store? And the answer is yes. It will tell the person who's buying the game that they need a controller in order to play the game. At the bare minimum, we ask that the main menu just works with the remote. And luckily, because of the way that our mapping works, up, down, left, right on the controller is the same as the remote. So once you have those axes mapped, everything works. But if a controller drops out or you don't have a controller, it'll tell you when you load up a game, hey, we haven't detected the controller, you may not be able to play this game. And Fire TV can support up to 7 Bluetooth game controllers. So only 4 of them are assigned to an actual player value. So if you look on the controller, they have lights on them. And this is more true for the older systems. So they only assign to 4 players. You can still have 7 of them, and you can get those out. You just have to go through Unity, and you have to query them individually as individual game controllers. I talked about this too. I can't really show it too easily, but I'll talk through it in the context of this game. But what screen am I on? Let me actually go back into full mode, and I'll show you. So, all right. So once we get into the game, start. I show 2 arrows. You also notice I only show the arrows when I need to. I hide UI when it's not needed. I show it when it is. If you are on, for right now, I have it just set a debug for desktop or for mobile. If it's on desktop, I wouldn't even show the arrows. There's no point in showing the arrows, right? I'd show some instruction maybe for left and right, but when you die, you become a ghost and you fly out through all the levels. So that being said, I go through and I also make sure that stuff like press anywhere to try again. Be very specific. I actually got my game dinged a few times in the submission process, but I was like, press X to continue. And it's like, well, there's no X on touch screens, right? So you have to go through and you have to make sure that you actually set this stuff up correctly. I believe I have a finding is going to be. See, this is the best problem with Unity is I can never find where my code is. I have a text manager, and the text manager will basically look for the platform and swap out based on a key the value for what platform you're on. So when you have text, I can say, hey, use a token for input A, and it'll automatically swap out input A for whatever that I map it to in that platform. So those little details sort of add up, right? That's the last 10% of your game. So making sure that you just know what platform you're on and that you're showing the right controls. Also, this is the most important one, at least for Fire TV. You have to detect the platform. So Fire TV will actually return touchscreen true. It's the bug with Unity. Unity just assumes that Android is Android across the board, right? So I built a utility called a platform detection utility, and all it does is I boiled down all input to 4 basic types, and they're prioritized by hierarchy, right? Joystick overrides keyboard, keyboard overrides mouse, mouse overrides touch. The bottom of the line is always going to be touch, right? That's mobile, and a mouse will always emulate what touch should be. Joystick needs to be prioritized above everything else. So if you're listening for input, I just say, well, whatever the prioritized input device is that's connected will return that value. Everything else will sort of be ignored down the line. This way you don't get multiple joystick inputs and keyboard inputs for some reason, stuff like that. The other thing I do is I detect what the platform is, and in the case of Fire TV, I actually remap what the device returns. So like I said, Fire TV is going to return touch enabled as true. I write a custom profile using the device model, and I say, nope, it's actually false. So when I configure my game, I have presets. So this works for anything. Like I have the Shield, the NVIDIA Shield, and like that's like a weird device because it's a controller attached to a touchscreen. And it's like, well, what's more important, right? So in my game, I might just say, well, for this game, I don't want you ever to use touch. I want it all to be through the controller, right? So it's not just our platform, it's like all these Android platforms and derivatives. So building a class like this is pretty important. I don't think I have time to really go into the class specifically. Let me see if I can actually find it. It should be platform utility. I'll run through it real quick. So here, I know, Unix line endings, blah, blah, blah. All right. So here I register platforms whenever I initialize this class. And you'll see here I have Fire TV. And I just simply override the fact that device model is Fire TV. And I internally, I have an enum that represents, it's not, actually, sorry, this isn't my enum. This is the built-in one. Each platform has a device type. So you can you can actually figure out whether the device is a desktop, whether it's mobile, it's a console. I remap Fire TV to be a console. That way Unity just acts as if it's a console, and it doesn't care. So I do the same thing for Fire TV and Fire TV Stick. And the new Fire TV is Amazon AFT-S is the key for that too. So, and then as you can see, like I just go through now, and whenever I add new platforms, ideally this would be in some sort of configuration file, but I just continue to add different profiles for how it should act. So, optimization. This is where we spend the majority of our development time. The biggest no-brainer one is going to be object pooling, right? So I have a lot of effects going on. Just because this game I could do a lot more than I could maybe in like HTML5, for example, doesn't mean that Unity is this like magical thing where you can just throw millions of particles at it. You need to do object pooling at the most fundamental level. So here's just an example of me running through. All of these guys are being pooled. When they hit the red zones, it basically destroys them, and then these green zones are spawners. And in the upper right, you'll see in the hierarchy what happens is that it continues to build each of these instances until it runs out. Once one gets destroyed, it gets grayed out and disabled, and then it gets recycled. And I have a pretty elaborate system for doing this. Definitely, usually I do this in a much larger talk when I go through it. But at a high level, the way that it works is I can turn any game object basically into a poolable game object. I just add a script to it. And the script has an interface called iRecycle. And what happens is that instead of using the built-in game object instantiate, I have a utility that I instantiate everything through. And when I instantiate it through that, it looks to see if there's a pool that exists for that object. So whenever I create an object and it has iRecycle, I see, oh, you have the iRecycle script attached to you in the prefab. I'm going to add you to the pool. But before I do that, I'm going to look to see if the pool actually has an instance of you, and then I'll just get that one first. If it doesn't, I'll create it. So this way, all I got to do is add iRecycle to any of my game objects, or any of my prefabs. And then my utility, I just make sure that whenever I create or destroy anything, it has to go through my utility. But this is also good because there's been times where I've needed to refactor the way that I create something or destroy something. And when you route all of your creation and destruction to a factory, it winds up giving you a centralized place. So a lot of the times, like a high level, I'll write one layer on top of Unity's own framework so that I can control the flow of how things get created, how things sit in memory, how things get destroyed, and that I have more control over it than just black box letting Unity take care of it. This, I should have shown this this demo. This is the most important thing possible, especially when you're doing 2D games, is putting everything into a texture atlas. So Unity allows you to work in 2D games by just throwing everything into sprites and just leaving as individual sprites in your artwork folder. Every single texture is a unique draw call. So what happens is that if I just did a Lynda course on optimizing, and the example I use is I have a tile map, and the tile map has 100 tiles in it, right? So there's 100 draw calls. And when I put all of them into a texture atlas, it goes down to one draw call. The reason is that all your images need to sit in one texture memory, right? One texture in memory. And then anytime you reference pieces of that, you don't get an overhead because Unity batches those kind of calls. If everything is an individual texture, not only is it sitting in memory, and worst case, if it's not like a multiple of 2, and it's not bitmapped correctly, then you're going to get double the memory because it's going to have to create a texture to fill it into memory correctly and then put it on. And each GPU, by the way, is completely different, right? Every mobile device has a different GPU, a different processor. So it gets incredibly complicated fast. But at a low level, if you just simply put all your stuff together either with Unity's own sprite packer or use something like Texture Packer Pro, you can literally turn scenes that have hundreds of draw calls into one. UI is a different beast. UI varies from being super optimized to incredibly not optimized. There's not much you can do around it, but so at the bare minimum, try to make your game as optimized as possible. If you're using Unity's new GUI system, you have to really be very careful. Even changes in the hierarchy will impact draw calls. But again, even if you're using textures in your UI, put the textures in the texture atlas. One last thing is also try to make there's actually a whole bunch of little tricks I'll tell you right now. This is over anyone's head because anyone just well, it's a texture atlas as I start going into really deep texture compression stuff. All right, so every type of texture has a different compression that is optimized per GPU, right? So I don't know them off the top of my head, but I know our new devices are using a different GPU than the last year's devices. So part of a Unity build is making sure that you output them in the correct way. A trick in Unity, if you're using the sprite packer, is that by default, it's going to package 2 separate sprites. It's going to do RGB and then ARGB, right? So you'll have anything that's on transparency will be separated out from anything that's not. What I do is I tell everything to be transparent. So just because it doesn't have transparency, it doesn't impact anything. I want one texture atlas, right? The only caveat is that every device has different memory constraints, right? So you can't go over 512 by 512 usually on mobile, or performance you get penalized actually on top of it. So there's all these different things you have to take into account. This is the opposite of the responsive game design talk where I'm you do this one thing that works everywhere. This is every specific device needs to be optimized, and that's why it's very, very important to do it and have the physical device to see the performance issues. So one neat trick, like I said, is you can combine, if you don't, a lot of my sprites are 16 by 16. So when I combine 100 sprites, it's not a very big texture map. Just try to take that into account. Simple lighting effects. So this sort of annoyed me. That example I showed in the last one about I took this HTML5 game and then I built it in Unity and slapped some lights on it and all this stuff. It's a very basic game, so it works. In reality, though, you can't just throw lights around and pray for the best. What I wound up having to do for this game is I went back to an old technique that I did in HTML5, and it's the simplest technique in the world. I just have a PNG with a transparency, and it gives it the shadow. So if I want to get that vignette, instead of having real lights, a PNG, and it's not even an extra draw call because it's all in the same texture atlas. So because of that, I try to simplify lighting wherever I want, wherever I can. So things like vignettes or shadows or simple things that you can just fake it. Just like in 3D, you would bake lighting. In 2D, you got to do the same thing. And it sort of sucks, but that's just the way that it is, or your draw calls just go through the roof. Unity's new UI components. I go back and forth over them. They're a lot better than anything else that's been out there, but from subversion to subversion of Unity, I've become an expert now. Like the difference between 5.0 to 5.1 to 5.2 has been drastic. 5.1 being the worst, 5.2 being the best, but 5.2 has other bugs that are problematic. Long story short, until you become a master of every subversion of Unity, their UI system is really good. And their layout engine is incredibly impressive. And the big thing about having the game scale correctly is that I can pin a UI to like an upper right-hand corner, and then it'll just move based on wherever the screen resolution changes to, right? So taking advantage of their built-in system works out really well. And there's like really cool stuff you can do, like even like a neat trick. Like before, I made this as like several different textures, this like health bar. Now I can just use their slider component, and I just pull out the handle, and I just make that. It in the slider component is pretty optimized. So instead of having to do everything manually like you used to have to do with the old GUI system, you can do some pretty good stuff. NGUI is still pretty good. I just never was a big fan of how they wanted you to structure stuff. I felt it was like a little convoluted, but they're also incredibly optimized. The weird thing with Unity's GUI stuff, and this is where I've noticed the problem, is that it's incredibly hierarchically optimized. So where you are in the hierarchy will literally have direct impact on how it batches and how it renders out. So a good example is it's going to do a single pass for textures that are batched within the same list of hierarchy. So if you have a button, let's say I have a UI with buttons, right? 3 buttons and they have text on it. It will try its best to do a batch where it'll do all the button backgrounds, then it'll do all the text on top of it. That's a good scenario. The game I'm working on right now, for some reason, even though everything looks like it's supposed to be correct, it's a keyboard, a virtual keyboard. Every single button is drawing individually. I have no clue why. So I went from some UIs that have like 3 draw calls to this UI, for some reason, has like 100 draw calls. So I have to go through now piece by piece and just refigure it out. So there's good things and bad things, but at the end of the day, like if you do want to get to all these different resolutions, check out their layout system, because their layout system for the components is definitely well done. So there's like so much to go into and optimizing and stuff. Like I'll probably like, if I have time, I'll go back and I'll dig a little bit deeper into some of the optimizing stuff that I do. Now testing on Fire devices. This is important. I mean, as much as it helps like Amazon's bottom line to have every device that we have, right? At least have one. Obviously, because I work there, I have a whole range. But having like the high end and the low end is always the best of any like platform holder, right? So testing on a physical device is critical. While like I said, you can just drag and drop an APK onto our dev portal and get a result of whether it'll run on a device. Like I said, each GPU is a little bit different from generation to generation of our devices. Even the Fire TV, the 2 generations have different GPUs in them. Right? So it's important just to actually have a physical hardware to make sure that it works correct. And even the difference between Fire TV Stick and Fire TV, Fire TV Stick is not designed for like super high-end 3D graphics, right? It's a totally different demographic. It's really made for casual games. It's our fastest selling product ever on Amazon.com. So a lot of people have them, but you got to keep in mind when you're going in, it's not going to run Halo, right? Like it's going to run some very good casual games, and if you need something with more power, then you're targeting Fire TV. But testing on either of those, different results, and it's important to see that. I was going to talk also for us. All you got to do is just output to Android. You don't have to do like a mixed build with like an Intel. We're just Android direct. So right, and you basically compile for ARM. Same stuff. You can target API level 17 and above. So so last year's Fire TVs, which are still on the older OS, are API 17. Our tablets are 19 now, as well as the new Fire TV because they use Lollipop. I'm like so bad at like I'm really good at the subversions of Unity, the subversions of Android. I'd say it's some sort of like dessert. That being said, you can target for 17 and up, and you'll get the whole range of devices. For Fire Phone, for Fire tablets, that hardware, you can just plug in USB and you set it up as a regular developer device, just like you would any other Android device. You go into settings, you find that one property and click it like a bunch of times, and it unlocks it as a developer device. Fire TV. And you can also we also have a way to enable and disable ADB debugging a little easier on our tablets. It's part of our options. And then again, all that's just done to USB, just like you would any other Android device. For Fire TV, you have two options. You can either do it through Wi-Fi, which is, like I was saying this morning, a little bit easier if your TV and Fire TV are on the other side of the room, or you can get a really long USB cable or a really short one and just keep it at your desk like I do. And then you can just do it through USB. So that will act just like a normal Android device, and you can do the profiler and debugging and everything you normally would do through USB. On Fire TV, every one of our devices is a dev kit, right? So retail or dev kits, just open it up, turn it on, go to settings, go to ADB debug, and then you're good to go. If you're doing networking, though, there's a few other steps. I prefer the networking unless I'm doing like really low-level debugging. In that case, all you do is you got to get your IP address for your Fire TV itself, and then in the command line, you just simply type ADB connect, and you pass it in the IP address, and it'll act as if it's connected. Like I said, the only thing you can't do is the profiler over wireless. And then also, if you just did ADB devices, you can get a list of all the devices you have. So where do we go from here? Looking at my time, I did this really fast because I want to go back through and answer some questions and go through some more of the technical stuff. I talked about the responsive game design. All this sort of builds up to where we are right now, right? So if you sat through the whole track, you should have like a really good like arc of build a game and design a game from the ground up that's going to go across all the devices you want it to run on. And also thinking through how to optimize it, knowing that the lowest common denominator is going to be mobile. Optimize for that first, and then you have a better chance of getting it to sort of run everywhere. And I talked a little bit before about just a blog post about publishing the games, which probably means the last slide is this. So let's dig a little bit more into this code, and we'll take a look at sort of like what's going on under the hood. So does anyone have any like specific questions about optimizing to like guide me through where I can like dig into? So open questions, anything you guys saw in this talk that you thought was interesting, I'm happy to dig into. So shy. I bet if I like gave away something, people would be more interested. Yeah, I can go into the pooling. I can show that example. So I should have a separate scene. Give me a second here. Scenes, staging, demos. Let's see if this runs. A lot of times my staging stuff stops working. The way that I work is I'll create a scene just for experimenting in, and then I try to move that into the main code. And then as I continue the main code, I break the old testing. So let's roll the dice and see. Well, it did something. Okay, it's giving me an error for something in the dictionary. It's probably because it can't find the array. But let's look at a high level, right? So here we are in this scene, and it's going to go through. And the first thing you'll notice is that I have this thing called we'll go into singletons. We can go into singletons too. Basically what happened is I go through and I requested a night prefab, and the night prefab on it has my iRecycle. So my game utility is like, oh, well, you can be recycled. Therefore, I'm going to create a pool, and if you don't exist in it, I'll add you to the pool. So here it'll automatically add each of these game objects as it goes through it. The other thing you'll notice, and this is important too, I don't even talk about sound, but since sound in Unity has to be played on a game object, it's one of the more expensive things you can have in a game. So I wind up object pooling sounds too. So I have a generic sound prefab, and the idea behind it is once you've set up and configured a sound, you can tell it to play anything. Why recreate the game object? So every time I continue to play sounds, it pools the sounds too. And because the pooling system is dynamic, I could set it up where I could say, hey, create 100 sounds ahead of time. If not, it'll just automatically just add sounds and create them as it needs it. I don't even think there's only like one sound in here. So to give you an example, this is my recycle sound class, and it has an audio source, which is your normal audio source. But in this, I tell it like, hey, you can self-destruct. So if I need a single play, it'll automatically destroy itself. I can have sounds fade in and out. And the reason why I route, so going back to why I add another level on top of Unity, is the biggest problem you have is, let's say you want to mute the sound in your game. Well, how do you know? Because Unity, you're just going to create a game object and let it float out into space. Since everything is going through my utility, I can now say, hey, well, give me the sound object pool and loop through all those and tell them to stop. Or tell them all to fade down. Or tell them to crossfade or do something like that, right? So now I know where everything is because I collect them correctly. Same thing with my knights. If I needed to go through, and let's say I wrote a behavior, kill all knights in the game, I could go through and I can query and look for all the knights, right? And look through give them a tag or something like that. But it's expensive. I can actually just say, well, I know the knights are going to be attached to the object pool. I'll go through and look through all the instances of that object pool for that specific type and delete them there. And then I don't have to do any extra performance or do a complex query. Like let's say you have hundreds of game objects, right? You wouldn't want to go through and search through all of them. So that being said, the basic idea behind the object pool is one of these scripts. I write a lot of scripts. I'm very big into modular code, so everything is very small and broken apart. Let's just look at, I'll just pull up the recycle game object. So this is it. It's the most complicated class on earth. All it does is it has an interface for recycle so that consistently I know how to restart. I know how to restart and shut down a class. And then and that's it. Like in this base level, what I do is I'm just concerned I don't want it to be running, so I enable and disable that game object. From here, I can actually, each of my other scripts inherit the iRecycle. And when I go through and I activate or deactivate a game object like this, I can have those methods on another script. So let's say when I recycle a knight, I need to reset all the health, right? So the knight's health, so let's say, let's look at the knight, like the knight AI. Extends my abstract AI. And somewhere in here I should have, you see here, he just directly extends the recycle game object. So I can do it either way. I can either make him extend the recycle game object, or I can have him call the methods. So here in restart. So this is all the stuff that I need to do in order to correctly restart my knight so that he's ready for the next instance. I just reset, his speed multiplier and his collision stuff and change his direction and all that kind of stuff, right? So I build these little pieces and build it up from there. The last thing I'll show is the game object utility, and then we'll probably wrap it up, right? How much? Should be coming up on time. I got 3 minutes. So this class here, like I said, whenever I need to actually instantiate something, I call my own game object utility. I call instantiate, I pass it in a prefab, I pass it in a start position, and whether it needs to restart or not. Sometimes you may not want it to restart. Sometimes you may just want to create stuff and just have it sit off the screen. So if I wanted to pre-populate the pool, I would just call instantiate 10 times, 20 times, 30 times, and then it just sits. Since restart has never been called, it won't be active. And then all I do here is I look to see if I take the prefab that gets passed in, I get the component. If it has a recycle game object, awesome. I go through my logic and I create a pool. If it doesn't have that script, I ignore it. And I do this all the time, stuff like when you want to have persistent game objects from scene to scene, I literally have one script that's just like persistent game object, and it just sets that one flag on it to be persistent. And this way, over time, you wind up building a library that looks something more like this, which is, this is my game right here. So I treat my project, it's so hard to see. I'll zoom it in, maybe that'll make it a little bit better. But early on, I kept all my code at like the root of the project, and then every time I added assets from the asset store, it just like broke everything, because I wanted them to be in a certain folder. Now I just treat every piece of my project as if it came from the asset store. And so basically, Super Paper Monster Smasher is the core of the game. But in here, I have this thing called Pixel Vision, and this is my framework. And inside of Pixel Vision, I have stuff like my camera logic. I have pooling. So all the classes that represent the pooling, from how the object pool works, the recycle game object, the spawner, all these things live inside of here. And over time, if you build the code small enough and modular enough, you can wind up building it. Like I build everything like Legos. And so I just keep building on top of this. But the key to anything when you code is making sure that you control the input and the output, whether it's constructing stuff from scratch or whether it's the actual input itself, because then you can actually optimize at like the core level. So that in a nutshell is sort of like how I optimize for our devices. Do the survey. If you guys can do this is the last survey for my talks at least. And as we wrap up, basically we're going to go to, I think we have like another break, and then upstairs is the rest of the day will be